Hi class, this video is on logarithms. Logarithms sound complicated, but they're basically the inverse of exponential functions. They just extract the exponent. They're actually quite simple, so let's get started. Okay, so what is the log base 10 of 1,000? Well, it's equal to 3. And let's check that on the calculator. Okay, if I put in log of 10,000, okay, I get out 3. And why is that? Well, basically because it's kind of like remove this 10 over here. 1,000 is equal to 10 cubed. So when I take the log, by the way, log base 10 is the same as log on your calculator. It just assumes base 10. Log base 10 of 1,000, I'm asking what number is 10 raised to equal 1,000? And that number is 3. If we have log base 2 of 16, that's equal to, well, it's asking for 16 is equal to 2 to what number? And that number is 4. And so log base 2 of 16 is 4. Log base 10 of 10,000 is equal to what? Well, we're asking is 10,000, it's equal to 10 to what number? And it's 4. So that number is 4. So we really just extract the 10 exponent out of this number. We're extracting the 2 exponent out of this number. Log base 3 of 9 is just equal to 2 because I'm taking the 3 exponent out of 9. 9 is equal to 3 squared. And so I'm just extracting that exponent. Okay. So in general, if we have log base a of x, and that's equal to some number b, then I just took the a exponent out of x and got b. That meant that x was equal to a to the b. Okay, I'm taking the a exponent out of x, and that's what it means. That's a logarithmic form. This is kind of the exponential form. They're inverses of each other, really. Okay. So what's log base 10 of 10 to the 7th? Well, what is the 10 exponent of 10 to the 7? It's 7. So that's what it's equal to. Log base 2 of 32, or 2 to the 5th, is just equal to 5. I'm extracting the 2 exponent out of this, and it's clearly 5. Log base 2 of 2 to the x, therefore, is just equal to x. What's the 2 exponent of 2 to the x? Well, it's x. And right there, you notice from our previous video on inverse functions, we have one function f of x, say, is equal to log base 2 of x, and we have another function inverse of x, or g of x, is equal to 2 to the x. They're inverses of each other because f of f inverse of x is going to be equal to log base 2 of of 2 to the x. What's the 2 exponent of 2 to the x? Well, it's just equal to x. Okay. Remember log base 3 of, let's see, 81. What's that equal to? Well, 81 is 3 to the 4th, log base 3 of 3 to the 4th. We're extracting the 3 exponent out of that, so it's just equal to 4. Okay. A way to remember the exponential form, this is the exponential form, and this is the log form. This is really the definition, is we really just kind of move this a over to there, and we get x is equal to a to the b. Okay. Well, let's see a graph of these. Let's go to our Desmos calculator. And I put these in already. And we have the function y is equal to 2 to the x, and that's this function that we saw before. And the line y is equal to x, and we have the log of log base 2 of x, and it looks like this. Those are inverse functions. Okay, whenever we have a point here, okay, that's a point 0, 1, then we have the corresponding point over here, 1, 0. Okay, y interchanges with x. This one brings it to some y, and that takes y back to x. So if we have the point right here, 2, 4, we're going to have the point here, 4, 2. Okay, it takes y back to x. And here we should have the point 3, 8, and we'll have the point 8, 3 over here. Okay, so every time there's a xy over here, there's a yx over here, and so it just flips it about the line y is equal to x. Okay, just flips it about the line y is equal to x, and that's what an inverse function looks like. Okay. So if we have the function f of x is equal to log base 2 of x, then we can put some values in for x. If x is equal to 2, then what do we have? Well, what's log base 2 of 2? Well, that's the same as 2 to the 1, so the exponent is 1, so we get 1. Okay. Now what about 1 here? If x is equal to 1, what's log base 2 of 1? Well, that's also equal to log base 2 of 2 to the 0, right? 2 to the 0 is 1, so that's equal to 0. So that points on every log function. Okay. And now, what about 1/2? What's log base 2 of 1/2? Well, 1/2 is equal to 2 to the minus 1. So there's our exponent. Just extracting the exponent is equal to minus 1. So we get 1/2 for x. We get minus 1 here. So 1/2 and minus 1. And what about log base 2 of 8? Well, that's equal to log base 2 of 2 cubed. So I'm extracting the 2 exponents, so it's 3. So I get 8 and a point 3. So I got 8 and 3 here. What about 4? I get 2, right? It's log base 2 of 4. 4 is 2 squared, so I get 2. And I get 2 here. And this function looks like this. The inverse of my 2 to the x. So here's a log function. Log base 2 of x. Okay, and what's the domain here? And range. Okay, well the range goes from minus infinity all the way to infinity. But the domain is I can only put in positive values for x. I can't put in a negative number. 2 to the x, it looks like this. It's never negative, so I can't get back there. Okay, so the domain is 0, infinity. And note that this is the range of the inverse of 2 to the x, and the domain, right, for 2 to the x, my domain is from minus infinity to infinity, but my range is 0 to infinity. And they flip for this one. And that's basically because every time I have a point on this graph, okay, I don't have it drawn well, but every time there's a xy over here, there's a corresponding yx over here on the inverse function. Okay. All right, so what did we do for inverse functions? Okay, so what do we do for logarithmic things? We got the graph of a log. It's the inverse of 2 to the x, and it just extracts the exponent. Okay, so I hope you found this introduction to logarithms video useful and helped you in your learning, and that you enjoyed it. Cheers.